Hi everyone, so today we're going to be taking a look on page 29 in your notes packet. So this is again page 29 in our Unit 2A packet. So we're going to be going through a bunch of problems today. Pages 29 to 32 serve as Regents review extra practice. So let's just get started with question 1. So question 1 says, solve for x and graph the solution set on the number line provided. And we're going to state the largest possible integer value for x. All right, well, here is my inequality. So let's start to solve this. Okay, so I'm just going to rewrite my inequality and let's get to it. So we have parentheses here so we can distribute. We also have that on the other side, so we're going to distribute. So we'll have 4x plus 8. Be careful, guys. You're only distributing here and here. You're not going to this -2 over here. Okay, that would be wrong. All right. So again, we're just doing that distribution. And let's go back to pink. We have 4x plus 8 minus the 2x. Okay, I'm just bringing down the inequality sign. 2 times 3x is 6x. And 2 times 8 is 16. Guys, you always want to look on either side of the inequality. Are there any terms we can combine on the left-hand side? And there are. We can combine, let's see, we can combine this 4x and negative 2x. Okay, notice I'm doing my color coding after I've done the distribution. Don't start color coding up here. Up here. Don't start color coding once you have to do the distribution first. Okay? All right, so now we have 4x minus 2x. Well, that's 2x plus 8, which is, again, greater than that 6x plus 16. We want to start to get x by itself. Guys, get x on the left-hand side. Okay, get x on the left-hand side. So I'm going to subtract the 6x on both sides. Again, notice the 6x gets paired with the 2x because we're combining like terms. We'll get negative 4x plus 8 is greater than 16. Okay, sorry, I'm running out of space here, so let's write this over here. We have negative 4x plus 8 is greater than 16. Okay, we're going to subtract the 8 on both sides. Now I have negative 4x is greater than 8. Guys, remember, when you divide by a negative, you have to flip that inequality symbol. So we'll end up getting x is less than -2. All right? So that's the solution to our inequality. So we just found x is less than -2. So let's sketch this on our number line. All right, so I just indicated the numbers here on the number line. Guys, make sure you're going from the lowest numbers, here, to then the greater numbers going to the right. Okay, so because we have x is less than -2. Right? This is going to get an open circle at -2, and the arrowhead says shade to the left, right? That arrowhead says shade to the left. Okay, so we have this way, right? We're going to shade it this way. Again, follow what the arrowhead says. Okay, let's erase that though. So now that we know we're shading this way, well, the next part says, state the largest possible integer value for x. So guys, if you look on this number line here, okay, what is the next largest number x value? Okay, so -2 we don't include because we have the open circle. What's the very next integer value you see? -3. So my largest possible integer value for x is -3. Make sure you guys go back and read the question. All right, let's take a look at question 2. So question 2, again, we're given function notation, f of x, okay? And we're saying determine the smallest integer that's going to make f of x less than 15 true. Okay, so now we want smaller. All right, well, if this is f of x, right, we want to set it less than that. So I have this -3x plus 7 minus 5x is less than 15 because f of x is going to be less than 15. Okay, so let's combine like terms on the left-hand side. And we end up getting negative 8x plus 7 is less than 15. Subtract the 7 on both sides. And we have negative 8x is less than 8. Again, remember, when we divide by a negative, we flip this inequality symbol. So now I have x is greater than negative 1. So again, guys, if it's hard for you to visualize this, because the next part says, determine the smallest integer value. Well, if I make my number line, okay, so let's just go negative 1, 0, 1. All right, sure. And maybe negative 2 and 2 here. We're at x being greater than negative 1, so remember that has an open circle. Remember we talked about this. Greater than or less than is open circle. Greater than or equal to or less than or equal to is a closed circle. It's really important. Okay, so again, look at where that arrowhead is pointing. We're going to shade it to the right. So I'm shading this to the right. It's really helpful to draw a number line. Guys, the question didn't say to draw a number line, but it's probably going to help you to do so. Now, the question says determine the smallest integer value. So negative 1 doesn't get included because it has the open circle. But what's the next number? What is the next number? It's 0. So the smallest integer value here is 0. Again, just always going back and making sure you're answering the question. All right, let's flip it on over. Let's take a look at questions 4 and 5. Now we're on page 30. All right, so for question 4, we're on page 30 now. We want to start to get x by itself. Now remember, we want x on the left-hand side. So I'm going to subtract x. Oop. We want to subtract x on both sides. Now, guys, remember, in your calculator, and I'm going to pull it up in a second, you should not be typing x's in the home screen. You should not be typing x's in the home screen. So when we combine these like terms, remember, what's the number out front of this negative x? What's the number out front? This is a negative 1. So let's type it in the calculator. All right, so I got my calculator out. I'm going to type in, we have negative 2/3. So the negative button is down here, guys. Negative alpha y equals enter 2 over 3. Now I have minus. Remember, minus is down here. This is negative. We want minus 1. Let's type 1. There you go. Negative 5/3. So now I have 7 minus 5 over 3x, which is less than negative 8, because those canceled. Again, we keep x on that left-hand side. So to undo this positive 7, right, there's a plus here. You don't see it. So to get rid of that plus 7, we're going to write minus 7 on both sides. I'll have negative 5/3 x is less than negative 15. Again, we're getting x by itself. Now, how do I get x alone? It's being multiplied by this negative 5 over 3. Somebody said it last week, and you guys did a great job with this. How do I get x by itself? We're going to multiply both sides by the reciprocal. What's the reciprocal of negative 5 over 3? Well, its reciprocal is negative 3 over 5. All you guys do is flip it. Flip the fraction. That's all it is. Doesn't matter if the negative's on top or bottom. All right, so we're multiplying both sides by negative 3 over 5 times negative 3 over 5. Now, we are multiplying both sides by a negative. What do we have to do with this inequality symbol? Whether I multiply both sides by a negative or divide both sides by a negative, we still need to flip the inequality symbol. So I'll have x is now greater than, note that change. Okay, now we're looking at greater than. Now, negative 15 times negative 3 over 5. Guys, that just goes in the calculator. Okay, when you put that in the calculator, we should end up getting 9. So my final answer here is x is greater than 9, which is answer choice 1. Okay, why don't you guys try question 5? So you guys can do question 5 now on your own. I'll post what the final answer is, but do question 5 on your own. You should end up getting x is less than or equal to negative 2. Okay, do it on your own. Our follow-up question, though, this part I will help you out with. So do part 5 on your own, the first part, but we're going to do this second part together. Okay, so the question says, is x in the solution set? Well, we just solved, okay, well, you're going to solve this, but I'm telling you what the answer is. X is less than or equal to -2. I'm going to draw myself a number line. So here we have -2, -3, -4, I have -1, 0, etc., right, on either side. And keep going. When x is less than or equal to -2, notice the equals to piece, so this is going to be a closed circle. And my arrowhead is saying to shade to the left. So we're going to go to the left. Is 8 in that solution set? We're going -2, -3, -4, -5, -6, -7, -8. It keeps going towards negative infinity. Is 8, which is way over here, way towards the end, my picture's not drawn to scale, is 8 in the solution set? No. And guys, the way that we can justify this is plug x in. Plug in 8 for x. So let's do that. All right, so I'm going to plug in 8 for x. So I have -8 times 8 plus 10. Is that greater than or equal to 26? We'll see. -8 times 8 is -64 plus 10. Again, I don't know. I'm going to put a question mark. Is this greater than or equal to 26? When I combine like terms here, guys, -54 is not greater than or equal to 26. So 8 is not in this solution set. Okay, but again, this will be done once you've solved for 5 on your own, and this is the answer you should get. All right? Okay, moving right along, let's take a look at question 6. Again, more practice. These are Regents problems. We have given this inequality of this 2x plus ax minus 7. That's greater than -12. Determine the largest integer value of a when x is -1. So now when x is -1, let's plug it in, right? Just plug in x to be -1. So I have 2 times -1. Never forget your parentheses. Minus 7 is greater than -12. Okay. So again, just going to simplify here. That's -2. That's minus a. Minus 7 is greater than -12. I can combine like terms on the left-hand side of the inequality. We have -9 minus a is greater than -12. I'm going to add 9 to both sides because we like a on the left. So we have -a is greater than -3. And remember, there's a -1 out front. So we're going to divide both sides by -1. When you divide by a negative, you flip that inequality symbol. So now I'm looking at a is less than +3. And our follow-up question, guys, says, determine the largest integer value of a. So what is the largest value of a that's in this solution set? Well, again, if you draw yourself a number line, let's see, 0, 1, 2, 3, 4, 5, right? And it's less than 3, so we don't include 3. It's that open circle. And our arrowhead's pointing to the left. So I'm going to shade to the left. Guys, what's the largest value before the 3? Okay, what's the largest value for x that's in this shaded red region? And our answer here is 2. So the largest integer value is when a equals 2. Make sure you go back and answer the problem. This here of a being less than 3, this is not my final answer. This helps you to figure out it's when a is equal to 2. All right, I'm just going to skip around. We're going to take a look at questions 9 and 12. So we have on page 31 now, okay, we have the Cardoso family is going to a movie theater and they want to purchase snacks at the concession stand. So we have the cost for a bag of popcorn is $6.25. The cost for a box of candy is $2. The family has $20 to spend on the popcorn and candy. They must purchase 2 bags of popcorn. If B represents the number of boxes, so now we have B represents the number of boxes of candy. We want to write and solve an inequality. Okay, inequality. Inequality, there should not be equal signs. You should not see any of that. You should be seeing greater than or equal to, less than or equal to, greater than or less than. So none of this equal sign nonsense. Okay, and we want to determine the maximum number of boxes of candy that they can buy. So let's go back to the beginning, guys, all right? This is a word problem. They're going to the movie theater, and they want to buy snacks at this concession stand. We know popcorn is $6.25. They're going to buy 2 bags of popcorn. So think about how we can represent that. The popcorn is $6.25, and they're going to buy 2 bags of it. Well, we can multiply those values. We have 2 times $6.25. Okay. We know the box of candy is $2. So I know on top of that, we're going to get candy, and the box of candy is $2. And I don't know how many boxes we're going to get, right? B represents the number of boxes that we're going to get of this candy. So each one is $2, and I'm multiplying it by, this is here, the number of boxes, which we called that B. So this is plus 2B, okay, plus 2B. And now we want to write an inequality to determine the maximum number of boxes we can buy. Well, guys, remember, this is dealing with money, and this is dealing with money. So our inequality, whether it's greater than, less than, greater than or equal to, less than or equal to, needs to be dealing with money on the right-hand side. You have money, money, this needs to be money. Okay, so let's see. Well, in this problem, we are told that we can spend $20. I can spend $20. So I can spend $20. Can I spend $19? Yeah, I can. Could I spend $15? Sure. What about $22? Nope. Now I'm above my limit. I only got 20 bucks in my pocket, so I can only spend that 20. So I don't have to spend all $20. I could spend less than that, or I can spend equal to $20. Do you guys see where I'm going with this? We can spend $20 or less. So we're going to use less than or equal to. This is less than or equal to $20. And now that we've set it up, that's the hard part. Now we're going to solve for B. All right, so why don't you guys pause the video here and solve for B. All right, so there I solve for B. I have B is less than or equal to 3.75. Now remember, B is talking about the boxes of candy. So B is talking about boxes of candy. Can I have 3.75 boxes of candy? No. Could I have 4? Well, okay, yes, you can have 4 boxes of candy, but is that going to fit this inequality? If we were to draw our number line again, 3.75, 4, 5, 3, 2, etc., right? You guys remember it's equals to, so we have that closed circle. And our arrowhead says shade to the left. So what is the largest number of boxes of candy we can have? And our answer is 3. So even though B was less than or equal to that 3.75, the maximum number for the boxes of candy we can have is 3. So let's write out a sentence. All right, I want to see you guys write me a sentence. So the maximum number of boxes of candy we can buy is 3. All right, let's move on to question 12. That's going to be our last question. So we have Megan joined a gym membership. Just reading the problem out loud. This is the last page, page 32. Megan joined a gym membership for $20 for a monthly fee of $20. She has a budget of no more than $100 per month. Guys, you need those context words. No more than is less than or equal to. She also wants to take yoga classes for $9. Y is going to represent the number of yoga classes. We're going to write and solve an inequality to find the maximum number of yoga classes she can take while staying within her budget. All right, so again, let's read that over. We have a monthly fee of 20 bucks. So I have to pay this $20 fee no matter what. Her budget is no more than $100. No more than $100. She also wants to take these yoga classes. So these yoga classes cost $9, and we said let Y represent the number of yoga classes. Okay, let Y represent the number of yoga classes. So I have plus 9Y. So again, we're dealing with money. Money, this is $20. $9 per class, where we said Y is the number of classes. And she can spend no more than $100. So there's my inequality, guys. Okay, I have 20 plus 9Y is less than or equal to 100. And you guys can do the rest of this. Solve for Y. All right, so now when I solve for Y, I end up getting Y is less than or equal to 8.8 repeating. Now, you can't take 8.8 yoga classes. So what's the maximum number of yoga classes she can take by staying within this budget? So again, draw yourself a number line. See if that helps. We have 8, 9, 10, right? I'm picking numbers above and below. So that 8.8 is probably here, right? So that's 8.8 repeating. It's equals to, so I'm going to make that a full closed circle, and I'm shading it to the left. So what is the maximum number of yoga classes she can take? She can't take 8.8. That doesn't make sense. And she can't take 8.5. We're only going by integer values. So the next number I see is 8. The maximum number of yoga classes she can take a month is 8. All right, guys, I hope you found this video helpful. If you have any questions, as always, you can come to Extra Help, and I'm more than happy to go over them with you.